And so all of last chapter was about linear equations, equations that when you graph them, they form a line. Except for the very last part, which was absolute value, but everything else was about linear equations. And so we're going to look at what's called systems of linear equations. And basically it's just multiple linear equations. You have more than one linear equation. And there's several ways to solve. And the first way we're going to solve is by graphing. And so for a solution, we are looking for an XY that works for both of the lines. All right. And so when you're talking about graphing, when you graph them, if the graphs intersect, then the point where they intersect should be a point or an XY that works for both of those lines, because that XY will fall on both lines. And so if you're solving by graphing, that's exactly what you do. You take both of those lines and you graph them individually, and then where they cross is your answer. And so this is a review from last chapter because we know how to graph. These are in slope-intercept form. So for this first line, y equals 2x minus 3. We're going to start at the -3, which is our x-intercept. And our slope is 2, or 2 over 1. So we're going to move up 2 and over to the right 1. And then we will connect those dots, and that will give us our first line. And then we're going to graph our second line. So our second line is y equals x minus 1. So we're going to start at -1. All right. And we're going to go positive slope of 1, up 1 and over 1. And you can kind of walk it sometimes and you'll see exactly where it's going to cross. But to graph it, you're going to connect those dots. And so we look and see where they intersect, and they intersect right here at this point. This point is 2, 1. And so my answer, or my solution to this systems of equations, would be 2, 1. What that means is if I were to plug in an x of 2 and a y of 1 into those equations, it should work for both of them. So you can always check it. With graphing, if you don't graph it exactly, sometimes you're going to be off a little bit. And so that's why sometimes it's easier to walk it. But if I were to plug this in, 2, 1, my y value is 1. For the top equation, 1 equals 2 times my x value minus 3. 1 equals 4 minus 3. That works. If I look at my second equation, y equals x minus 1, my y is 1 equals x minus 1. Yes, that works. And so my answer for this particular one would be the point 2, 1. When you're solving these, your answer should always be an xy value. Always be an xy value. So the first way we're going to solve is by graphing. So go ahead and try. through this one. If I'm graphing this top line here, I'm going to start at +5, and my slope is up 1 over 1. You'll notice that I walked 2 points here just to make sure my lines were a little more accurate. So I went up and right and down and left. Those are both positive slopes. For the second one, my y-intercept is 0. A -4 slope is down 4 and right 1, or up 4 and left 1. And you can see when I went up 4 and left, I crossed exactly at -1, 4. -1, 4. For this second one here, the blue line here, if I start at +2 with a -1/2 slope, down 1, right 2, or up 1, left 2. For this second one, if I start at -3, down 3 and right 1, up 3 and left, and then I went up 3 and left again just to see exactly where it would cross. All right, so oftentimes if you keep walking, you will cross exactly where you need to cross for these lines, and you can see exactly that I crossed at -2, +3 for that one. All right, so suppose you're testing 2 fertilizers on bamboo plants A and B, which are growing under identical conditions. Plant A is 6 centimeters tall and growing at a rate of 4 centimeters per day. Plant B is 10 centimeters tall and growing at a rate of 2 centimeters per day. After how many days will the bamboo plants be the same height? What will their heights be? All right, so when you're talking about word problems, an initial condition is your y-intercept, okay? An initial condition is your y-intercept. And if it says per day, per this, per that, then that is your slope, all right? So if my number of days is my x, that's what I will have. My number of days is my x. My height will be my y, all right? And so it wants to know about their height. So my height is based on how much it grows per day. So if I'm talking about the first plant, all right, so let's say plant A. My height for plant A is going to be based on how fast it grows. So how fast is plant A growing per day? 4. So 4 centimeters per day is how it's growing. And I started with what height? 6. And so I'm going to do the same thing for plant B. All right, my plant B's height is going to be based on how fast it's growing. How fast is that one growing? 2. And when did it start at? Started at 10. And so this is what this is going to look like. Now, for something like this, you'll notice I only have my first quadrant because my plant will not be a negative height. All right, nor will I have a negative number of days. So I don't even need my other quadrants here. All right, something else is it's automatically 1 through 10, but on this particular one, I may not want to do that because I start at 10 for one of them and I have a slope, a positive slope no less. So I may want to go back to this guy and say, I'm going to do this every 2 because that's going to make more sense in what I actually need to do and how big I want my graph to be. All right. And so there are times in a word problem that I don't necessarily want to go by ones. All right. So I may want to change this to something like this to make it easier to graph this particular one. All right. And then I'm going to graph it exactly the same. If I start with my y equals 4x plus 6, my y-intercept is 6, so that means this plant is going to start at 6 inches. And it's going to go up 4 inches for every 1 day, So if I go up 4 inches, that'll be up to 10, and then 1 day would be right here. 4 inches more in 2 days. All right, and that's how this particular plant is going to grow. And it would look something like that. All right. It probably won't go indefinitely, but we can put an arrow there. For the second one, I'm going to start at 10. And for this one, I'm going to go up 2 inches for every 1 day, 2 inches for every 1 day. All right. And that particular graph is going to look something like this. All right. And it says, after how many days will they be at the same height? Well, we're going to look at where they cross. They cross right here at 2 days and 14 inches. And so that's why it's important to realize that I put my days as my X and my height in inches as my Y. Because when it says after how many days, my answer would not just be 214 for a word problem. That does not answer my question. All right, my question is answered by saying 2 days, they will be the same height, and they will be 14 inches. And so for a word problem, you would want your answer to look something like that, not just an XY pair, because this is going to define the question and answer. So check your work. For the first one, it starts out at 5 centimeters, so that's your y-intercept. It grows at a rate of 2 centimeters per day, so that's your slope. The second one starts at 11 centimeters and grows at 1 centimeter per day. When you graph it, and I just left these as number of days because I knew I wouldn't go past 10 days. I did this by twos. So I started out at 5, went up 2 for 1 day, up 2 for 1 day. And you'll notice I just kept walking this one because they are going to cross after several days. And so I just kept walking to see exactly where they crossed. For this one, starting at 11 and go up 1 centimeter for every 1 day, 1 centimeter for every 1 day. And if you keep walking that one, you're going to see that you end up at 17 centimeters after 6 days. So 6 days, 7 centimeters tall is where these two would cross. All right, no solution. So what do you notice about these two graphs? Well, I have the same slope here, and I have different y-intercepts. So when I graph these, the first one's going to start at +1 and go down to, and I should have done more graphs, down to and over 1. And the second one's going to do the same thing. And so we're going to have these two parallel lines here that happen. All right. With this one, you don't really notice it as much. So I have the y equals -1/2 x plus 2. All right. And this one is not in slope-intercept. So I'm going to put it in slope-intercept form. I'm going to take 2x plus 4y equals 8, subtract my x over, so 4y equals -2x plus 8, and divide by 4. Y equals -1/2 x plus 2. What do you notice about these two lines?
They're the same.
They're the same. So if I do this particular one, no matter whether I graph the red line or the blue line, I am going to get that line. So these are special cases. First case, where will these two lines intersect? Right here.
Never.
Never. They're parallel. So when you have parallel lines, you have no solution whatsoever. No solution. Because they will never intersect. There will never be an XY that makes both of them work. All right? When you have a situation like this one, where they are the same line, you have an infinite number of solutions. It's the entire line. So your answer is actually the line itself. Your answer for this one is y equals -1/2 x plus 2, because every single point on that line works for both of those lines because they're the same line. And so these are special cases. If they're parallel, you will have no solution. If they are the same line, the entire line is your solution, and you just give me the entire line's equation. And so these are the three types of answers you will get. The first type is they just intersect at one point. That XY value is your answer. It works for both of them. It's where the two plants are the same height, all right, after a number of days in the height. This is parallel, all right? They have different y-intercepts, and they grow at the same exact rate. Think of it as our plant. If you have a plant that starts out at 4 inches and a plant that starts out at 6 inches, and they both grow at 1 inch per day, assuming they infinitely grow, they'll never be the same height, all right? Ever, okay? So this is same slope, different y-intercept. This is same slope, same y-intercept. This is the same exact line. This would be like two plants that are both 6 inches tall, and they both grow at 1 inch per day. When will they be the same height? Every single day, because they start at the same height, they grow at the same rate, okay? And so that would be the entire line would be your solution there. All right, so those are the three types of answers you would get for these. You would get one answer, they intersect, no answer, they're parallel, or infinite answers, they're the same line.